So we heard a lot about dreams yesterday, and I have to share that I dreamt last night that this talk went horribly wrong. It starts off with suddenly it's an older version of the talk, and then someone else's slides come in, and so you may be in for an interesting 15 minutes, which is not a phrase you often hear from my talks. There we go. Right, strategic knowledge gaps, which is a far better way of saying stuff we'd quite like to know. And so, better acronym. So there is a perception that strategic knowledge gaps essentially are requirements. They have to be closed before we fly somewhere, and that isn't true. Strategic knowledge gaps they're both destination-centric, but they're also architecture-centric, and they're essentially sort of three flavors of SKGs. There is have-to-have requirements. We cannot go to this place using this methodology without this information. But I would argue that's actually, for a lot of those there aren't that kind. We have to have it there so we can say there aren't any, but then the most common is sort of by knowledge that if we have, it buys down risk. And a good example of this, I think, are the lunar module footpads. When the lunar module was being designed, as someone touched upon yesterday, we didn't know what the bearing strength was of Regulus. There was a talk, it could be anything from solid rock to talcum powder, and things were going to land and never be seen again. So you can design for that. You basically design for the worst case. But by having knowledge in key areas, you can design something that's lighter, and that helps you. And then finally, you've got mission-enhancing strategic knowledge gaps. These are particularly, you see these for the lunar ones. This often applies to resources, that if you know this information, you may design systems that let you go for longer or take less with you. There's 4 sets of SKGs, Moon, Phobos, Deimos, Mars, and NEOs. The lunar ones and the Phobos, Deimos ones were redone last year. The lunar ones are out, the Phobos, Deimos ones are very nearly out. And one of the complaints that we often got was that these weren't easy to find. So one thing we've been working on is making the laser work. No, anyway, we now have a good web portal, that you can go to and then download them in a standard format. And so, accidentally going to the next slide. So, part of the title of my talk is opportunities, and a good one that we just heard about a couple of these are the EM1 secondary payloads. The first SLS flight will take 13 CubeSats. There are a variety. All 3 NASA mission directorates, the technology, the science, and HEO are flying CubeSats, as well as some of our international partners. And I do think that this is, we're getting to the point where we're actually going to demonstrate what CubeSats can do in a deep space environment. And I do think that represents an exciting opportunity going forward. We're already looking at EM2, and all future SLS launches will likely have spare mass capacity to take these CubeSats. So, I mean, some will work as advertised, some won't. We will still learn enough. We will still learn about technology and start to get data. And I think the interesting thing again is the cadence of these is such that it's a lot of flight opportunities for people coming through to actually work on flight hardware, which is incredibly valuable. So just touch upon a couple of these. Lunar Flashlight is a lunar CubeSat that will look for volatiles on the surface inside permanently shadowed regions. It's run out of JPL. Barbara Cohen is the science PI, and this uses 4-band laser to essentially look at the 3-micron band inside permanently shadowed regions. The other part of yesterday is we were asked to give advice. There was a lot of advice given to the next generation of scientists coming through. So clearly, I put in this slide as an example of it's good to check that you look at the program to see who's talking immediately in front of you. But it's here as an example, not because I didn't do that. But Pam's already told you lots of good stuff about IceCube. So then we have the Korean Pathfinder Lunar Orbiter, particularly exciting opportunity that HEO is conducting with the Korean Space Agency known as KARI. They've got a lot of Earth orbit experience. They're flying their first lunar orbiter later this decade. They very kindly they offered NASA a payload opportunity and also participation in joint science teams. HEO is working with the Science Mission Directorate to come up with our participating scientist program that we hope to have the AO for that come out later this year. And that will allow US-based scientists to be on both the Korean and NASA-sponsored instrument. NASA picked a single instrument. We selected ShadowCam. Mark Robinson from ASU is the PI. ShadowCam is a modified NAC, similar to flown LRO, with updated, very sensitive electronics. This allows it to essentially image in the dark. It can use the reflected light from the inner rim to get data inside the permanently shadowed regions of a resolution of better than 2 meters. There's a number of SKGs and science that comes out of this. They're looking, their signal to noise is such that they can measure, they can look at detailed albedo changes, so they can look for craters that have brought up volatile rich regolith that may have a brighter albedo. They can also, by going down to below 2 meters, if you can go down to 2 meters from the boulder distribution, you can then infer all the way down to the decimeter scale, which means they can look at the craters where mini-RF sees bright, and they can bright high CPR only inside the craters, and they can make an estimation whether this is due to volatiles or because those craters are in fact rocky at that scale. It complements the 4 Korean instruments. LUTI is a roughly 5 meter high resolution camera. PolCam is a polarimetry camera. Then there's a gamma ray and a magnetometer. And Dr. Ju from the Korean Space Agency is actually giving a talk tomorrow morning, an overview of the entire Korean Space Agency lunar exploration program. So he'll probably go into this in more detail. So HEO is very aware and interested in the long-term getting the commercial side involved in lunar exploration. Many of you may have heard of the Catalyst program. This started in 2014. This, we competitively selected from the private sector. At that time, the 3 most promising candidates to fly a commercial lander were Astrobotic, Master Space Systems, and Moon Express. Whilst it's no exchange of funds, what it is NASA sharing both technical expertise, test facility, equipment, and software. And also, I know that all 3 of these companies feel that Catalyst has been very beneficial to helping them get closer to getting to the moon. We've also had a couple of RF surface payload and transportation RFIs recently. In November of 2016, there was the small lunar surface payload RFI, which was essentially where we went to the community and said, once this commercial lander capability exists, what type of instruments would be available from the community to fly, and what are the approximate resources, mass, power, cost, etc., for those instruments? As part of that, two of the commercial partners came up with a cost sharing. Both Moon Express and Astrobotic have come up with a way of sort of working with NASA to jointly cover some of the cost. Then an ongoing RFI that was launched May of last year was similar, but this time it was going to re-looking at what commercial partners are out there and saying, what do you think your commercial lunar capabilities will be for taking things to the moon in the next few years? All of this provide inputs to what we hope are potential RFPs for actually flying things, asking the community to propose instruments that fly to the moon to either do science or help with SKGs. Okay, I'm not going to so Resource Prospector, just so people are aware, this was a HEO-funded, very exciting mission, and we saw a great talk earlier, went to the details of what it will do. I think from one sentence, Tony Colaprete describes it well, which is what RP will do is it will provide the information that we need to help plan the future systems to the moon if we get to the scale of really wanting to do a resource, no longer prospecting, but a generation. What is sort of the quality of the ore that you can actually, what do you want to do next? He says badly. Okay, so now the Deep Space Gateway. I wanted to touch upon that because it's been talked about quite a lot, and I want to explain what it is and it isn't. So the Deep Space Gateway is, you'll see this called Phase 1. Phase 1 for HEO is essentially the initial operations in cislunar space. So Deep Space Gateway is designed for deep space environments. It's what we do with crew after station in order to give us deep space experience. It will be visited by Orion. It will be crew tended, not permanently visited like station, permanently occupied, but it can take, initially we're thinking a crew of 4 for roughly 42 days, and then they leave and another crew can come back, roughly 11 months later. It also supports build-up of a deep space transport, which is the crew vehicle for going further into the solar system. Right now, it consists of a power propulsion element, which is based on the asteroid redirect mission propulsion bus, a habitat logistics module, and we're also looking at both science and crew airlocks. Now, there we go. So it uses SLS to launch. This is the type of chart that changes regularly, but the principle is correct, which is the Deep Space Gateway will be built up in time. The first module, the power propulsion bus, is set to go up on EM2, and then every subsequent SLS rocket will launch a major module. Now, where those modules come from they will come. There's potentially 3, if you like, suppliers. There's NASA supplied, there's US commercial supplied, and there's international modules. So we've been running something called the Next Step Habitation BAA to look at how the commercial industry in the US could be best used to provide elements for Deep Space Gateway. Phase 1 had the 4 companies shown coming up with concepts. We're now in phase 2, where the companies shown bottom left are actually going to build ground prototypes, and this we hope will lead into phase 3, where some subset of these will actually be chosen to supply a commercial element for the Deep Space Gateway. So my last 2 minutes, I've presented before on this ISEG science white paper. It's now essentially complete. ISEG is the International Space Exploration Coordination Group. It's 15 space agencies, which NASA is a member. It allows them to, all the agencies to talk about how best to work together in the future. Its primary document is the Global Exploration Roadmap, which talks about Mars being the horizon destination, and it talks about 3 sort of significant destinations that you could choose to get to Mars via. One is the Deep Space Gateway in the lunar vicinity, one is the lunar surface, and one is asteroids. We were tasked to come up with a white paper that, working with the science community to say, if this is what human spaceflight is going to be, what science do all 3 of those destinations enable? And the idea was to get the international science community involved and hit all disciplines. So my last chart is so one of the chapters in this is the science enabled by humans at a Deep Space Gateway in the lunar vicinity. And this just highlights sort of the breadth of science that you could choose to do once the gateway's there. And some of this science is because you've got a crew there, and other parts of this science is just because you've got infrastructure associated with the crew there. As I mentioned, the crew's only going to be there roughly 1/10 of the year at a time. It doesn't mean the gateway can't facilitate science during the other 11 months. As a result of what's come out of the white paper, NASA is now starting the process to look at a detailed workshop to take this into the white paper covers very high-level information. What we're doing with the workshop is we want to delve into the next level of detail to say, okay, in all these branches of science, helio, fundamental physics, collecting interplanetary material, what actual instrument, what scale of instruments would you actually want to fly to do decadal level science? And Jim Spann from Marshall is going to give the next talk, which will go into more details of what we hope to achieve in the workshop. And it's something, the workshop is something that will only be successful if the audience here, really gets involved. Thank you.
All right, we have time maybe for one quick question. Jim the Cube.
So what's a typical business plan for commercial use of the gateway?
So when I said commercial, the commercial aspect of the gateway is NASA paying a commercial provider to build a node. Longer term, the gateway could provide regular access to could facilitate easier access to the lunar surface. It could provide comm relay to a commercial asset in lunar orbit. So it's enabling in a number of ways that perhaps lowers the bar for commercial